Hi guys, welcome to Algebra 1 Semester 2, Day 15. Today we're going to look at one variable and two variable inequalities and working on graphing and solving them. We're going to start this lesson off with talking about one variable inequalities, and we're going to talk about how to solve them. First thing we want to talk about is called interval notation. Interval notation is one way of expressing an answer to an inequality. It's going to use parentheses and brackets to show where your number line is going to start and stop. The parentheses means that it's not included. This would be where you would have an open circle, and you're going to see and use parentheses when we're talking about less than or greater than, or whenever we're talking about infinity or negative infinity. So whenever your graph is going to either positive or negative infinity, we're going to use a parenthesis to talk about that. Brackets mean we want to include that number in our solution. So when we've got greater than or equal to or less than or equal to symbols, or we're going to have a closed circle on our graph, that's when we're going to want to use that sort of square bracket to show where it starts and stops. Basically, solving an inequality works exactly like solving an equation with one exception. And that is when you multiply by a negative, we want to reverse the symbol. That's the only time we're going to mess with that inequality symbol, is when we multiply or divide by a negative. And I'll show you what that looks like as we go through these examples. All right, let's look at number 4. We want to solve solve, graph, and write the solution to each inequality in interval notation. So when I look at example number 1, I notice that all of my x's are inside the parentheses, and that whole set is being multiplied by 4. So we could handle this in one of two ways. One way is we could distribute that 4 through the parentheses, or since all of the x's are inside the parentheses, we can undo that multiply by 4 by dividing both sides of our equation by 4. This is going to make our lives a lot easier in the long run if we undo that division before we go, or multiplication. So 4 divided by 4 is just 1, so we're left with x plus 3 on the left. The symbol stays the same, and then negative 24 divided by 4 would be negative 6. Now, since we multiplied it by a positive 4, we're going to leave the symbol alone. So that symbol is just going to come straight down. And then it works, again, just like an equation. We're adding 3 to x, so we want to undo addition with subtraction. So I'm going to subtract 3 from both sides. That symbol is going to come down and it's going to stay the same. And we get x is greater than negative 9. Now, we want to go over and graph this on our number line. That negative 9 is our dividing point. So on my number line, I'm going to put negative 9 in the middle. Then we can count up to the right and down to the left. And we're going to draw a circle on negative 9. Now, because this is just a greater than symbol, that means we're going to have an open dot. If it would have the equals sign underneath it, then we would have a closed dot and we would fill in our circle. Now, we also know that x is greater than negative 9. So that means we want to shade everything to the right of negative 9 on our number line. We can always double check this to make sure we're right by plugging in a number like maybe 0, which is greater than negative 9, into our equation. So if we took 4 times 0 plus 3 we would get 4 times 3. And we're kind of asking, is this true? So is 12 greater than negative 24? And the answer to that is yes. So we know we've shaded in the right direction. Now, to write our answer in interval notation, we start with the lowest possible value, negative 9. And since we're going all the way to the right, that means we're going to infinity. And since we are only greater than, we want parentheses on both sides. So that's called set notation, and that's a way to show the answer, or I guess interval notation, that we want that interval between negative 9 and infinity. So x could be anything from negative 9 to infinity. All right, let's try another example. When I look at the structure of this inequality, now I have an x outside of the parentheses and an x inside of the parentheses. This is where we would want to distribute that negative 3 through, because we're going to have to combine those x's before we start undoing this equation. So that first x stays alone. Negative 3 times x would be negative 3x. And then negative 3 times positive 2 would be negative 6. That is probably a place where you could make a mistake, is when you're multiplying that negative 3, make sure that negative comes along for the ride. Then is greater than 4. Now we have two terms with x's in them, so we can combine those. So we have positive 1x minus 3x is negative 2x minus 6 is greater than 4. Now that all of our x's are together, we can start to undo the operations. So we want to undo addition and subtraction first. So I'm going to add 6 to both sides. So negative 2x is greater than 10. Now I want to undo multiplying by negative 2, so I'm going to divide by negative 2. Now, here's where we really have to be careful, because when we divide or multiply by a negative number, we're going to have to flip that sign around so that now it is at a less than instead of a greater than symbol. And then 10 divided by negative 2 is negative 5. So that's where you want to be careful, and when you multiply by a negative, you want to reverse that symbol. Negative 5 is what's going to divide our number line. So I'm going to put negative 5 in the middle. I'm going to count up to the right. I'm going to count down to the left. And we're just a less than symbol, so it's going to be an open dot. And now we want x is less than negative 5. So I'm going to shade this to the right, or to the left, sorry. Now let's double check to see if we made the right call. And let's pick a number that's less than negative 5. Let's say maybe we put in, I don't know, negative 10. So if we have negative 10 minus 3 times negative 10 plus 2, we want that to be greater than 4. So is that true? So negative 10 minus 3 times negative 10 plus 2 is negative 8. Negative 10, we have negative 3 times negative 8 is positive 24. Negative 10 plus 24 would be 14. So is 14 greater than 4? That's the question we want to answer. And the answer is yes. So we know we did this in the correct order. The interval notation here, we would say that we want to go from, now the lowest value we are going to is negative infinity. And we want to go to negative 5. And we're using parentheses on both ends because we're not equal to either endpoint. And I notice I forgot to do that on the first one. So negative 9 to infinity. All right, let's look at example 3. Okay, again, I've got x's outside of the parenthesis and x's inside of the parenthesis, so we are going to want to distribute that information through. So 7x, negative 2 times x would be minus 2x. Negative 2 times negative 4 is positive 8. Be very careful there. Is less than or equal to negative 2. We can combine like terms. 7 minus 2 would be 5x's plus 8. The symbol comes down exactly as it is. Now we can start undoing. So we're going to undo the addition. So we get 5x is less than or equal to negative 10. And undo that multiplication. So we get x is less than or equal to negative 2. So negative 2 is going to be our center point. Count up to the right, count down to the left, and that's where we're going to draw our circle. Now, because we have that equals to bar underneath our symbol, we're going to color in our dot and make it a closed dot. That's our indication that we're going to be equal to that point. And then since x is less than, we're going to shade to the left. All right, let's pick a value to check and make sure that we've shaded in the correct direction. I'm going to pick negative 4 to check. So we're going to go 7 times negative 4 minus 2 times negative 4 minus 4 is less than or equal to negative 2. 7 times negative 4 is negative 28. Negative 4 minus 4 is negative 8. Negative 2 times negative 8 is positive 16. Negative 28 plus 16 would be negative 12. So we ask ourselves, is negative 12 less than or equal to negative 2? And the answer is yes. So we know we've done this in the correct order, and our graph is headed to the left to negative infinity. So my lowest value is negative infinity. That always gets a parenthesis. My highest value is negative 2. And because it's closed, because it's equal to, we're going to use a square bracket at that point to indicate that that's going to include negative 2 in the answer and not exclude it like the open dots and parentheses do. All right, one more example for us to do together, and then I will have you guys work on some independent practice. So I have an x inside the parenthesis, an x outside the parenthesis. So I am going to want to distribute that negative 8 through. Negative 8 times x would be negative 8x. Negative 8 times negative 1 is positive 8. Minus x is less than or equal to 28. I have negative 8 x's and a negative x, so we get negative 9x plus 20 or plus 8 is less than or equal to negative 28. Now my x's are together, so I can start undoing the addition by subtracting 8. Negative 36, and dividing by negative 9, because that 9 is negative. Now, when you divide by a negative, this is that spot where we're going to want to flip our symbol. And so we get x is now greater than or equal to positive 4. So positive 4 is our dividing point. So that's going to get a circle. Because we're equal to, that circle is going to be colored in to make it a closed circle. And our answer says x is greater than 4, so that means we are going to shade to the right. We can count up on our graph, count down, and let's pick a number to try. Let's pick 5 to try for our test to make sure we've done this correctly. So negative 8 times 5 minus 1 minus 5 is less than or equal to negative 28. So negative 8 times 4 minus 5. Negative 8 times 4 is negative 32. Negative 32 minus 5 would be negative 37. So is negative 37 less than or equal to negative 28? And that is also true. That's a yes. So we know we've done this correctly, and our graph is going from 4 to infinity. So the leftmost value is 4, the rightmost value is infinity. It's always a parenthesis with infinity, and because it's a closed bracket, we get a closed circle, we get a square bracket to show that we want to include that in our answer. All right, that's page 81. Your part of your independent practice for today is to do page 82. I probably recommend pausing the video now, completing page 82, and then coming back to watch the rest of the video. All right, thanks guys. Have a good day.